All right. On Friday we did that like the sugary moles to grams or grams to mole practice thing. And if you completed that, then you might have turned it in up here. But if you didn't complete it yet, there'd be time today to like work on that and finish that. If you were absent, or if you're remote and you didn't get it done yet, in the folder for last week, there is uh, it says sugary grams to mole practice activity, so you can turn it in there. But if you were if you were remote or absent, you don't have access to the stuff, the actual the actual candies. So if you click on the sugar or stoichiometry intro to mole candy remote, then that has some data that's pre-filled for you to be able to complete the work. So like up here, just has like these numbers like 4 blue or 3 yellow or 12 red or 6 black uh, as an example, or like what would be in a bag. So we use the little M&Ms, like the little mini M&Ms. Is that what they're called? M&M mini M&Ms? I don't know. I don't like M&Ms, so I don't know. The candy's no good. I'll eat the peanut M&Ms because then there's more stuff on the inside than the outside, but that's how that goes. Then in the folder for this week, 4-day week this week, um, the first thing that's in there is the thing that says Stoichiometry Maze classwork, and then there's a submission spot for the Stoichiometry Maze worksheet. So here's the deal: on the front side of that, if you pick one up on the way in, there's one that says Stoichiometry Maze Level 1. We're going to work through that together, and then on the back, there's one for you to practice. We'll do these a bunch of different ways, but this Stoichiometry Maze worksheet, it's like a conceptual idea to help you figure out ways to convert between quantities of like volumes, numbers of particles, masses, numbers of moles, stuff like that. And anyway, and we'll do more stuff with limiting reactants throughout the week this week. And then there's no class on Thursday or on Friday. We have in-service on Friday. So anyway, the Stoichiometry Maze classwork, it's a PDF file. So I mean, it's not as an editable file because the way it's like laid out, laying that out in Word would be a nightmare. Anyway, it's just a PDF, so it's just an image. And if you're remote, you could, sketch it on a piece of paper or something like that, or figure out which the ways to go, or just look at it on the screen. But anyway, the way it works is up in the upper left-hand corner, there's a thing that says start, and then down in the lower left-hand corner, there's a thing that says finish. So like a maze where you might have a roadblock and then a path to get to somewhere else, this activity is a conceptual activity to get us from the start to the finish. We don't know what path it's going to be, and that's the thing that you're going to figure out. And then, so we'll do the first one together, and then the one on the back, you can do it as a practice. Let me switch to this other thing. So for instance, the path that we take, we don't know. Maybe it's going to be like this way, and then it goes down here, and then over here, and then like this, and you get back to finish. Or maybe the path is like this way, and then, oh, not like that. It could be like this, and then going like that. In the boxes, there are arrows. So as a hint, there's only one way that you could go. In other words, in this activity, if you're here, it's impossible that it's going in that direction, or this direction, or this direction, or that direction. The only two possible ways from this box are in this direction and that direction, because there are arrows shown. And that's partly because there might be an alternative answer using the same kind of concept. So you must only choose a direction that has an arrow that's going in the right way. So the only ways that you could go, like the blue arrows are no go, the red arrows are possible. Those are possible directions. If we end up in that box, it's either going this way or it's going that way. So anyway, I zoomed in on the upper left-hand corner. So it says, choose the correct mole ratio setup for the following. How many moles of iron 3 chloride can be produced from 2.9 moles of chlorine? So in other words, we know the quantity of chlorine we start with. We're trying to figure out how many moles of iron chloride you end up with. And in the reaction, it looks like that for every 3 chlorines, we make 2 iron chlorides. So, I mean, how you would figure that out is you start with the 2.79 mole of chlorine, and then you'd use a mole ratio to convert from number of moles of chlorine into moles of iron chloride. So you got a choice. It's either going to be 2 moles of iron chloride on the top and 3 moles of chlorine on the bottom, or it's going to be 3 moles of chlorine on the top and 2 moles of iron on the bottom. Well, you know that if you're going to convert from like moles of one chemical into moles of another, whatever unit you start with is going to have to be in the denominator, like moles of chlorine. And then whatever you convert to has to be in the top, iron chloride, FeCl2, FeCl3. And in the mole ratio, there's 3 mole of chlorine for every 2 iron chloride. That's this selection here. So the correct mole ratio to get you from moles of chlorine into moles of iron chloride is this mole ratio. This one's wrong because it relates moles of iron to moles of chlorine, and that's not what the problem is trying to figure out. So the correct direction from this box is to go over here. So now we're in this box in the upper, or in the next one over to the right. And from this box, we could either go over to the one beside it or go down to the one below it. And this problem has nothing to do with the previous one. It's a standalone thing. It's all by itself. It has nothing to do with how we got to the box. We want to find the molar mass of silver chloride. So, you know, one thing that you should be able to do is if you see the name of the chemical, silver chloride, silver on the periodic table is Ag, and chloride is from the chlorine, and that's this thing here, AgCl2. So if you want to know what the molar mass of silver chloride is, it's the mass of 1 silver and 1 chlorine. You have 1 silver. Oh, well, it doesn't really matter the way you do it. Ag, you have 1, and chlorine, you have 1. So chlorine's like 35 and a half. I don't know, I gotta find the periodic table. Thought I had one handy. Let's find one. Courses, Chem 1. There's one. Silver is 107.87, and then chlorine is 35.45. When you add those up, there's only one of each, so really you're just adding up the formula masses. That's 142.32. And that's one of the choices. So there's 286.64 and 143.32. The reason why there are 2 choices, and this is an important idea, is the silver chloride itself is just AgCl. The 2 out front helps you with the mole ratio, but silver chloride itself, you would not multiply this mass by 2. See, if you were to multiply 143.32 by 2, you get 286.64. But the point is, the silver chloride itself is just AgCl. So we're just going to go to the right, and now you're in this box over here. So this is the formula mass, 143.32. And now from this box, we have 3 choices. It could be the mole ratio, it could be Avogadro's number, or it could be the molar mass. What's used to convert between moles of a known to moles of an unknown? Which one is that? Is it molar mass, Avogadro's number, or mole ratio? Mole ratio, sure is. Just like we did in the first one, this is a mole ratio. It's a ratio of the number of moles of chemicals. So we want to go from moles of one to moles of another. That's a mole ratio. So we've gone down to this next box that's down here. And there's only a couple different paths you could take. So in other words, when you're in this box, the 287.64, the arrow goes the wrong way, this goes the wrong way, that goes the wrong way. So from this box, we can only go a couple different directions. Hold on, I gotta get a different page. Let's see, previous. Gotta copy this down. Make it bigger. There we go. So what's the unit that can compare two or more quantities of substances together? So um, two or more quantities. So quantity is like counting. It's like a number of. It's like how many of the things do you have? It's either the only choices here from this box are where the arrows lead from. It's either going down with grams or going over with moles. Which is a quantity? Moles or grams? Moles, like numbers of, like how many you've got. Gram is a mass. So if we wanted to compare different masses, that'd be in grams. So we're definitely in moles. So this is the next box. And from this box, we only have two choices. We can either go to the right or go down. Going to the left is not a choice. Going up is not a choice. Um, Going to the right or going down is a choice. So what's the first step in grams of a reactant to grams of product? So in other words, maybe you have like a chemical equation. I don't know. Maybe it's hydrogen and oxygen or making water. And maybe we know we've got like 13 grams of hydrogen and we want to figure out how many grams of water we end up making. The question is, or I guess the choices are, do you take the mass of hydrogen in grams and convert to moles, or can you take the mass of hydrogen and directly convert to numbers of grams of the other chemical? Which is true? Can you convert directly from grams to grams, or do you have to convert to moles first? Convert to moles. Yep. If you don't start with a quantity of, that's in moles, you must convert to moles. Like if you start with a mass in grams, number of atoms or molecules, a volume of a gas in liters, the first step is to convert to moles, right? Like you'd convert from the mass of hydrogen into a number of moles of hydrogen, then use a mole ratio to convert from moles of hydrogen to moles of water, and then finally convert from moles of water into the mass. So converting to moles is a step you can do. Now, it turns out that if you make an incorrect step, sometimes it takes you to a box that is kind of useless or meaningless or unrelated to science. You might see that there's an arrow that's labeled astronomy. We didn't really talk about astronomy a whole lot, although there are astronomical concepts related to chemistry. So that one seems kind of not so useful. But where do you find the molar mass of a substance? Well, it's either related to numbers of coefficients or it's on the periodic table. And the periodic table lists the mass. So that takes us to this box. We want to convert between moles and grams. So that's maybe you've got a quantity like 3 moles of iron and you want to convert that into grams. Well, you could put a mole of iron in the denominator and then like the formula mass, maybe iron is 55.85 grams, just as an example. But if you're converting between moles and grams, this concept, how many grams there are per mole, that's the molar mass, not the mole ratio. Mole ratio converts from moles to moles, but molar mass converts from moles to grams. So now we're in this box. And what's wrong with that setup? Well, I don't know. There's a mass in grams of sodium hydroxide. And then in the denominator, it says 1 gram of sodium hydroxide. And the numerator says 40 moles of sodium hydroxide. Well, when you do a conversion to get you from grams to moles, what matters is what the formula mass of sodium hydroxide is. So I don't have a lot of space. I'm just going to write it over here. You have Na, O, and H. Maybe that 40 isn't a number of moles, but maybe it's the mass. Sodium is 22.99. Oxygen is 16.00. And then hydrogen is 1.01. When you add those up, you get 40. So it looks like the 40, that didn't complete. The 40 is the molar mass in grams per mole. The choices from this box either are the molar mass numbers aren't right, or the units don't cancel. Well, you know, if you start out with grams of sodium hydroxide, it's correct to have grams of sodium hydroxide in the denominator. But this conversion factor is written incorrectly in that the mass is in the wrong place. The correct conversion factor would be 1 mole of sodium hydroxide is the same as 40 grams. So it's not that the mass or the units won't cancel, the units of gram will cancel, but the numbers are in the wrong place. What's correct is to put the unit or the mass with the molar mass from periodic table and just 1 mole. So the numerator should have said 1 mole and the denominator should have said 40 grams. So the molar mass numbers are wrong. Now we're to the end. So the correct solution to this one we did is to go from, we went from this box over to this box, and then over to this box, then down to here, over to here. You would never visit a box twice. That doesn't make any sense because it would be as if there'd be multiple paths or something. And down to here, then we went this way, and then this way. And got to the end. So that's the correct path. And it turns out we visited, you know, a lot of the boxes in that example. Over to here, here, down, over, and like that. So the one on the back is the same kind of plan. It turns out that there are, instead of there being 12 of them, there were only 9 boxes, but you're going to end up down in that lower right-hand corner, like at some point. So it says what mass in grams of hydrogen is needed to react to 1.46 grams of methane. You're going to have to do the work maybe, like to write more stuff out. So instead of it just being conceptual in terms of like ratios and whatnot, you've got to do the conversions right. Now, another thing that's good about this kind of example is if you calculate the wrong value, it won't be a choice, and that means that you made a mistake. So if you think you got an answer and it's there as one of the choices, then you probably did it right. If you get an answer and it's not a choice, then you did something wrong and you're going to have to like refigure it and whatnot. So anyway, the plan is that you can do the stoichiometry maze on the backside, and to submit that, you could take a picture of it and put it in the like submission spot, or if you complete that and you're in class and you want to turn it in, that's cool. So the stoichiometry maze, and if you didn't complete the candy thing from Friday, yeah, the sugary grams to mole practice, if you didn't complete that on Friday, you want to complete that too. So that's what's got to get done. Cool beans? All right. You need a periodic table to be able to get your conversions good. I can put one up on the screen. Let me get a, tell you what. You know, the one we have in the course is pretty good because it's basic and it's easy to see. Let's see, WHS periodic table. So if you want to work together, or you want to work at a lab table, that's okay. Let me get this full screen. New share. Does that look okay? It's mostly readable. This one's more readable. I gotta get a better projector over here. Maybe like $600. Okay, more